this is Dr. Swapna and I welcome you all to your Learn Lab, your one stop for learning. We would be looking at a small topic today from Block 2. It's called Factorial Designs. This is an important tool for anyone who's intending to do research in future. So, without wasting much time, let's see and learn all about it. But first, let's quickly recap two important terms from another paper which we have already learned. It's Psychological Research from BPCC 105. The first term is independent variable. This is any variable that the researcher manipulates or vary in an experimental study. I'll explain this with an example, but let's look at the second term before that. The second term is dependent variable. This is any variable that is measured to study the effect of the independent variable. Okay, so for example, suppose we want to study the effect of drugs on depression score. Okay, so here the effect of drugs would be our independent variable. Why? Because this will be the variable that you as a researcher will manipulate or vary, like maybe using different drugs or maybe different dosages of the same drug. That is your prerogative. Either you can be using different drugs and different dosages, any combination of the factors. So this would be the independent variable which you would be changing. And what is the dependent variable here? The dependent variable will be the depression score, because whatever changes you are making in the independent variable will be visible in your dependent variable here, which is the depression score. So I hope these two terms are clear to you, independent variable and dependent variable. Now that we have seen what is a dependent and independent variable, let's see what are factorial designs. Factorial design is a technique used in research that allows researchers to investigate the effects of two or more independent variables on a dependent variable. So this is a statistical technique which is used to study the effect of two or more independent variables on a dependent variable. Let's take the example, the earlier example we are using. We said to study the effect of drug on depression score. We know which is the dependent variable, which is the independent variable. How many dependent variables do we have? One, which is depression score. How many independent variables do we have here? One, which is the effect of drug. So does this qualify to be a factorial design? No, it does not, because we have only one independent variable here. So if we have to make this into a factorial design, we need two independent variables. So let's add one more independent variable here. So that would make it like, for example, to study the effect of drugs and therapy on depression score. So now I have added another independent variable here, which is therapy. So now this qualifies for a factorial design study. Okay. The independent variable is considered as a factor. This term factor in factorial design stands for independent variable. The main effect as well as the interaction effect are studied with the help of this design. What is the main effect? Main effect would be the individual effect of each of the independent variables. In the example that we were using, effect of drug would be one main effect, effect of therapy would be another main effect. The interaction effect would be the combined effect of both on the dependent variable. All possible combinations of levels of the independent variables are studied to determine their individual and combined impacts. Now let's see how is it done. How do we study using factorial designs? The first step would be decide the objective of the study. So let's go ahead with the same objective that we have been using, for example, to study the effect of therapy and drug on depression score. Okay. Now identify all the independent variables and all their levels. What are the independent variables here? One is therapy and one is drug, and all their levels. Let's use two levels each. One would be with therapy, one would be without therapy. For drugs, let's keep it simple. Let's use one with drug and one without drug. Okay, so I have two independent variables here. One is the therapy, second is drug. And within each independent variable, I have two levels each. First one with therapy and without therapy. Second one with drug and without drug. So I'll be studying the effect of using therapy and drug on depression score. So the third step would be create all combinations of different levels of the independent variable. So how are we going to create different combinations? This would be, for example, I am using the first combination of drug and plus therapy. I'm using both. Okay. Next, the second combination I can use is I can use therapy without drug. Okay. The third combination I can use is no therapy with drug. The fourth combination that I can use is no therapy, no drug. So I have 4 different combinations of my levels of independent variables. What do I do next? Next, assign participants randomly to the different treatment conditions created by the combinations of factor levels. So we know the 4 combinations we have. Now we are going to assign the participants randomly to these 4 combinations. And then next we'll measure the dependent variable for each participant in each condition. After we have assigned the participants to these, we'll provide or we'll treat each of these participants with these conditions, and then we'll measure the dependent variable, which is the depression score. Last step, we'll do data analysis using statistical techniques such as ANOVA. I hope this is clear to you. Next, let's see what are the types of factorial designs. The first type we'll look is n into k factorial design. Here, there are 2 independent variables with n and k categories or levels. So, n into k means we have 1, 2, 2 independent variables, and under each independent variable you can have n number of levels or k number of levels. In the earlier example that we were using, we had 2 levels each under our independent variable. In case we are using religion as a independent variable, in that case we can have what? Any number of, howsoever number of religions you know, that can be the number of level. You can use 3 levels wherein you can add Hinduism, Christianity and Muslim, or you can add Sikh and make it 4 level, or you can add Jainism and make it 5. Similarly, any number of levels you can add to your independent variable. So this n and k can assume any number depending on your research or study. We'll see some examples of n into k factorial designs. The first one we'll look into 2 into 2 factorial design. What does this mean? This means we have 2 independent variables, and under each variable we have 2 levels each. So the definition says, for a 2 into 2 factorial design, there are 2 independent variables, each with 2 categories or levels. So this is same as the example we were looking, to study the effect of therapy and drugs on depression score. This is our first independent variable, this is our second independent variable, and this is our level 1, this is our level 2. This is the level 1 for drug and this is the level 2 for this independent variable. So I hope this is clear to you. Here we have 2 different independent variables, and under each we have 2 different levels, and then we'll be making combinations. Plus drug plus therapy would be one combination, plus drug minus therapy would be another combination, minus drug plus therapy would be one combination, minus drug minus therapy would be another combination. Next, we have another example. We have 2 into 3 factorial design. So now, without me telling, you should know what 2 into 3 means. This means again we have 2 independent variables, and under first variable we have 2 levels, and under the second variable we have 3 levels. Okay, so there are 2 independent variables, one with 2 categories or levels and the other with 3 categories or levels. So let's say take the same example to study the effect of therapy and drugs on depression score. Here under therapy, which is our first independent variable, I have 2 levels, plus therapy and minus therapy, which means this would be treatment with therapy and this is treatment without therapy. And the second independent variable, I have drugs, and I've got 3 levels here. I'm using 3 different drugs to check the effect. Okay, mine would be drug 1, drug 2 and drug 3. So I have 3 levels for my independent variable here. So this is my 2 into 3 factorial design. So in the examination, if this question comes to demonstrate the types of as well as draw this to show the combinations. Like there it would be plus therapy and drug 1. This would be plus therapy and drug 2, plus therapy and drug 3. Here would be minus therapy and drug 1, minus therapy drug 2, minus therapy drug 3. Okay, these are the combinations you will get for this study. Let's look at one more example of n into k factorial design. This is 3 into 3 factorial design. So here again there are two independent variables, and under each independent variable we have three levels or categories each. Example, if you want to study the effect of IQ levels, this would be our independent variable 1, and adolescent stage, this would be our independent variable 2. On behavior, this would be our dependent variable. And for our first independent variable IQ level, we have three categories or levels: high, intermediate and low. And for adolescent stage also we have three categories, which is early, middle and late. You can make this table on your own and write all the possible combinations. That would be how you have to write in your exam. Next we have the second type of factorial design, which is n into k into l factorial design. So I hope you have guessed by this what this means. This means there are three independent variables, and each variable can take n number of, k number of or l number of levels. These n or k or l can be any number. As the size of the factorial design increases, the complexity also increases for the study. Let's look at some of the examples. The first example we have under n into k into l factorial design is a 2 into 2 into 2 factorial design. Okay, so here we have three independent variables, and under each independent variable we have two levels each. Let's take an example. Study of effect of gender, which is the first independent variable; managers, second independent variable; third, socioeconomic status; on professional performance, this would be our dependent variable. So we are going to study the effect of these three independent variables on our dependent variable, which is professional performance. And under each of our independent variable we have two levels each. Let's see. First, gender, we have males and females. This is the two levels of the first independent variable. Under managers we have junior and senior. This is the two levels under our second independent variable. Third, socioeconomic status, high and low. These are the two levels under our third independent variable. These are examples that I've taken from the study material. Some I have made on my own. Maybe you can create more of your own for the purpose of exam if you understand the concept. We have another example for n into k into l factorial design here. This is a 3 by 3 by 3 factorial design, wherein we have three independent variables, and under each independent variable we have three levels each. Let's see an example. The effect of socio-economic status, which is the first independent variable. Second is phases of adolescence, second independent variable, and IQ level, which is the third independent variable. On behavior, here behavior would be the dependent variable on which we are going to study the effects of these three. The first independent variable, socioeconomic status, has three levels: high, middle and low. The second one, phases of adolescence, has three levels: early, middle and late. The third, IQ level, has high, intermediate, low. So this is our 3 into 3 into 3 factorial design. So now we know what is a factorial design. We know what are the different types of factorial design. Let's look at the data analysis part now. Two-way ANOVA is used to study the main effect and interaction effect of two independent variables on the dependent variable. We know what is an independent variable. We have seen what is a dependent variable. We have also seen what is the main effect, and we have also seen what is the interaction effect. Both independent variables are categorical and can have two or more categories or levels, and there is one dependent variable that is continuous in nature. This also we have seen. Let's look into main effect and interaction effect in detail. Main effect is the mean difference among the levels of one factor. How many factors do we have here? We have two factors, therapy and drug. And under each factor we have how many levels? Two levels each. Okay, so If you remember the video on Way ANOVA where we had solved questions also, we know that we have levels and we have numbers under these and we calculate the ANOVA. In case you have any doubt on this thing, you can go back and watch the Way ANOVA video. You will have more clarity on what we are talking here. So under each level, we have a number each. Okay. So mean difference among the levels. This is one of the levels. These are the two values under these factor and level. Mean difference among these two will give you the main effect of this level. Okay. Here, similarly, we'll have one number here, we'll have one number here. If you take the mean difference, then we'll get the main effect of using minus therapy, which is the level under this factor. Similarly, if you take mean difference among these two numbers, we'll get the main effect of the level plus drug. Similarly, if you take mean difference among these two numbers, we'll get the main effect of this level minus drug. So across the row, we have a main effect. Across this row, we have another main effect. Across this column, we have one main effect. And across this column, we have another main effect. So what is main effect? It's the mean difference among the levels of one factor. Similarly, interaction effect. This is the effect that interaction between two variables has on the dependent variable. So, what was the dependent variable in our case? Depression score. Now, this is the interaction between two variables. So, we have this combination here, plus drug plus therapy. So, these two levels will interact with each other and has an effect on the dependent variable, which is the depression score. That is the interaction effect. Similarly, we have more combinations, that's plus drug minus therapy, minus drug plus therapy, minus drug minus therapy. All of these will have individual effects, separate effects on the depression score. This would be the interaction effect. The other one was individual effect, which we call main effect. Interaction effect in two-way ANOVA can also be effectively displayed in the form of a line graph. So we have been talking about graphs in almost all of our videos. Here also we have a graph, the interaction effect, like how two independent variables interact to form an effect on the dependent variable. That can be plotted in a line graph. And when we plot that, we get three different types of interactions. First is a parallel interaction, second is a additive interaction, third is a crossover interaction. Let's look what each of these are. First, parallel interaction. Parallel lines indicate that there is no interaction between the independent variable in their effect on dependent variable. So we have a line graph here. So you need to understand this graph. This can be a bit tricky. So here how you have to read this is the male zone. Okay. So whatever line you see in this area will be for males and this is the female zone. So whatever part of the graph comes here would be the female zone. And this is their dependent variable. So what is the dependent variable here? Self-concept. This is another example I have taken from the study material only. So maybe you can go and check for more details. And so what are we doing? We are studying the effect of socio-economic status and gender on self-concept. So here on the y-axis, we have self-concept. On the x-axis, we have the gender, males and females. And these we have two lines here. One is for high socio-economic status and one is for low socio-economic status. So how do we read this graph? We say that males, okay, having high socio-economic status, whoever falls, males or females, whoever falls on this line has high socio-economic status. Okay, whoever falls on this line has a low socio-economic status. So when you read the graph, you know this is the possible positive part. This would be increasing this way. So males with low socio-economic status has a lower self-concept compared to males with a higher socio-economic status. Similarly, for females, females with a low socio-economic status has a lower self-concept compared to females with a higher socio-economic status. I hope you know how to read the graph. So this way the values increase, this way the values increase. Corresponding to this point we have here, corresponding to this point we have here. So this value will be lower than this value. So that's why we say males here with lower socioeconomic status will have a lower self-concept compared to males with a higher socioeconomic status. So what is a parallel interaction? Here both of them don't seem to interact with each other. Like here also the interaction, both of them seems to be the same. Like lower the socioeconomic status, lower the social self-concept. The gender is not affected by the socio-economic status. For both genders, be it male or female, the lower socio-economic status means lower self-concept. Higher socio-economic status means higher self-concept. So there is no interaction between the independent variable on their dependent variable. That's why we have a parallel interaction here. Make sure you remember this line graph, because if the question comes about this, you might have to draw this also. The second interaction is additive interaction. Additive interaction means there is some interaction between the independent variable with regard to their effect on dependent variable. So we don't know exactly what is the interaction, but we know that there is some interaction, that is additive interaction. So if you look at the graph, so in the parallel interaction we had no interaction, we had two parallel lines. Here the lines will not be parallel to each other. Let's take the same example, effect of socio-economic status and gender on self-concept. Here we have self-concept on the y-axis and the value will be increasing this way. So this is our male region and this is our female region. This is our line for low SES and this is our line for high SES. So what does this mean now? So here we mean that when it is low SES, the self-concept seems to be the same for male and female, not much difference in self-concept. Okay, but here high SES, we see that males with high SES have a lower self-concept compared to females with high SES, which means even though here there is no difference, some difference is being shown here between the gender and is some relation, interaction is there between the gender and socio-economic status. I hope you understand that. Let me explain this once again. We have two lines here. In one, literally there is no difference between the self-concept in males and females of low socioeconomic status. When it comes to high socioeconomic status, the males have lower self-concept compared to females. So there is some sort of interaction happening here between the gender and the socioeconomic status on self-concept. We'll have the next. Next we have crossover interaction. So here there is a complete interaction between the independent variables with regard to their effect on dependent variable. So first we saw parallel where there is no interaction. Then we saw additive where there is some interaction. Third we have crossover where there is a complete interaction. Okay, let's see how. So again, we use the same example to study the effect of socio-economic status and gender on self-concept. Here on y-axis, we have self-concept, which the value is increasing this way. This is the male region of the graph. Any line on this region would be for males and any line on this region would be for the females. And this line is for high SES. This line is for low SES. Now let's read the graph. Here, let's start with high SES. Males with high socio-economic status have a lower self-concept compared to females with a high socio-economic status. Why? Because number here would be higher than the number here. Similarly, if you look at the low socio-economic status, males with the low socio-economic status will have a higher self-concept compared to females with a low socio-economic status. So let's not confuse this. This line is for high socio-economic status. The part of line which falls under the female area would be for females, and part which falls under the male area would be for males. So how do we read this? We read that males with high socio-economic status will have lower self-concept compared to females in high socio-economic status. Similarly, males with low socio-economic status will have a higher self-concept compared to the females with lower socio-economic status. So here there is a complete interaction between gender and the socio-economic status, and they have a combined effect on the self-concept, which is the dependent variable. I hope this is clear to you, the three types of interactions. Let's see the advantages of factorial design. The first advantage is that it has the ability to investigate multiple factors in a single experiment, which can save time and resources. We can have multiple levels under each independent variable, and we can create all the possible combinations for all these levels and then study the effect of all of these combinations on the dependent variable. So all this can be done in a single experiment. This saves a lot of time and resources for the researcher. The second one, it helps in identification of main effects and interactions, providing a more nuanced understanding of the relationship between the variable. Not only the main effect, which is the individual effect, using factorial design, you can also study the interaction or the combined effects of the different levels of independent variables. Third one, increased statistical power, and it improves the likelihood of detecting meaningful effects. So factorial design has high statistical power, and it will help in identifying any meaningful effect that there is between variables. Flexibility. It's used in multiple fields including psychology, education, medicine, and engineering. Let's look at the disadvantages of factorial design now. The first one would be increased complexity, mainly when interaction effects are present. So when you have different levels under different independent variables, you will have different combinations. And when all these combinations are involved, the study becomes more complex. It becomes more time consuming. It becomes more resource requiring. So the second one, increased sample size requirement. Same logic, more the combinations that you have studied, there will be a need of increased sample size. Potential for confounding. Confounding means we have an independent variable, we have a dependent variable. There's a chance that there could be a third variable, confounding variable, which is not a part of your study, but which will have an effect on both independent variable and dependent variable. But since you're seeing a effect on dependent variable, you will think that this is because of your independent variable, when it will not be because of it. So this is called confounding. So as your number of combinations increase, it becomes more complex, and there is a chance for confounding, where a third variable can affect your dependent variable and independent variable and give you false results. Limited generalizability. So factorial design, more the complex, there would be less chance that you can generalize your result. Generalizing means whatever result you are getting for your sample, you will be extending that to the whole population. That generalizability will decrease with the factorial design. So this was all about this topic. Let's look at some of the questions that have come in your previous years. So the first one I have here is from December 2024. This says explain factorial designs, describe two-way ANOVA and its main effects and interaction effects. So this we have already discussed. So you have to explain what are factorial designs, and then you have to describe two-way ANOVA, main effects and interaction effects. Under interaction effects, it's a 7 marks question. So you have to tell about the parallel, the additive and the crossover. You have to draw the graphs also. The second question we have from December 2023, it says elucidate factorial designs with the help of suitable examples and diagrams. Again, same thing. You have to tell what is a factorial design. You have to say the types of factorial design. Each of them you have 2 into 2, 2 into 3, 3 into 3 and 2 into 2 into 2, 3 into 3 into 3. Give the examples and draw the diagrams. So next we have a short question. Write short note on the following in about 150 words each. We have one degree of freedom, factorial design. This came in June 2023. So there is a good chance that you can get this question. So I have already discussed everything that can possibly be asked from this topic. So that was all about today's topic, factorial design. And if you have understood the topic, this video was easy for you, hit the like button and let me know. Feel free to share it with your friends and subscribe to know when I'm going to put the next video. That's me, Dr. Swapna, signing off. Keep learning with me. Take care. Bye-bye.